Hello guys, welcome to organic tutorial classes. You can please do subscribe on this channel and also comment if you have questions and other things. Well, my name is Zainab and today we'll be going to organic nomenclature. So when we say nomenclature, it means name, like the set of rules used to the set of rules we assign to name organic compounds. Now let's start with alkanes. Let's start with alkanes. Now, as we all know, alkanes are the saturated hydrocarbons. We have the CH4 methane, we have ethane, C2H6, and the rest. So now, in naming alkanes, what we are going to consider, we are first going to consider the parent chain. We are going to select the longest chain, and that longest chain is going to be our what? Parent chain. Now, let's take this for example. Let's say we have let's start with the unbranched alkene. Now, this is an unbranched alkene. Now, it has 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It has 5 number of carbons. And we know an alkene containing 5 number of carbons is known as pentane. Alkanes always end with what? A-N-E. A-N-E. The parent chain should always end with what? A-N-E. It's showing that it is an what? It is an alkane. Now, an unbranched, this is an unbranched chain, which I know everybody is familiar with the unbranched chain. Now, for the branched chain, you can have something like this. Now, when you have a branched alkane like this is a branched alkene. Now, when you have a branched alkene, the first thing we are going to do is we are going to count to find our longest chain. Now, the longest chain is going to be our what? Our parent chain. Now, let's start counting. This is 1, 2, 3, 4, 5. Or if you count it this way, 1, 2, 3, 4, 5, it's still 5. 1, 2, 3, 4, this is 4. 1, 2, 3, 4, this is 4 also. 1, 2, 3, 4. Now, as you can see, we are going to take this as our parent chain. Now, this is our longest chain. So, if this is our longest chain now, this methyl groups, this methyl group and this methyl group are called the substituents. This is a substituent. Now, this is the parent chain. Now, these two methyl groups are the what? Are the substituents. Now, this first methyl is in position 3. The first methyl is in position 3, while the second methyl is in position 4. That's if we are counting this way. If you are counting this way, the first methyl is in position 3 and the second methyl is in position 4. Now, let's try counting it this way. Now, if you are counting it this way, this is 1, 2, 3, 4, 5. Now here we have methyl in position 1, 2. We have the methyl in position 2, 1, 2, 3, and methyl in position 3. So now when we sum these two numbers, 3 plus 4 is 7 and 2 plus 3 is 5. So now we are going to take the one with the least number. We are taking the one with the what? Least number. I'll repeat again. I said when we are counting from this side, we have methyl in position 3 and another methyl in position 4, which is going to give us 7. While counting from this side is going to give us methyl in position 2 and methyl in position 3. 2 plus 3, which is 5. Now we are going to take the one with the least number. So if we are going to name this, we are going to say 1, 2, 3. Since they are the same, since we have same substituents, that it's methyl and methyl, it's going to be 1, 2, 3. It's going to be 2, 3. Now since they are 2, and we're writing the numbers, we put comma. If you have like 5 methyls, you have 1, 1, 1, 2, 2. You always put comma in between the numbers. Now since we have 2, we are going to use the prefix di. We are going to use the prefix di. Now since we have 2 methyls, we have 2, 3, then a dash. Not like this, not 2, 3, dimethyl. No, this is wrong. We have 2, 3, then dash. Dimethyl. Then our parent chain is what? 1, 2, 3, 4, 5. Now our parent chain is pentane. So we have 2, 3, dimethyl pentane. And that's all for this. So let's look at another example. We can have C. Now we are given this to name now. So now we are going to look for our longest chain, that's our parent chain. We are going to count it from left to right, from right to left, to find which one is going to be our parent chain. Now let's start counting from here. Now we have 1, 1, 2, 3, 4, 5, 6, 7, 8. If you should count it from this side, it's still going to give us 8 number of carbons. So let's count from this side. 1, 2, 3, 4, 5, 6, 7, 8. It's still 8. Now let's count from here. 1, 2, 3, 4, 5, 6, 7. And this is 7. 1, 2, 3, 4, 5, 6, 7. This is 7 too. This is 7 too. 1, 2, 3, 4, 5, 6, and this is 6. So we are going to take this as our what? As our parent chain, since it is the longest chain. So now we have about 1, 2, 3, 4. We have 4 substituents attached to this parent chain. We have 3 methyl groups and 1 ethyl group. So now, if we are counting from here, we have a methyl in position 2. Then we have ethyl position 5. And 2 methyl groups in position 6, 6. Now when we add this, it's going to give us 2 plus 5 is 7. This is 19. Now let's try counting it from this side. 1, 2, 3, 4, 5, 6, 7, 8. Now counting from this side, we have 2 methyl groups in position 3. We have 3 plus 3. Then an ethyl group in position 4 plus 4. And another methyl group in position 7. So now let's sum this up. We have, this is 17. So we are going to take the one with the least number. So now we have we have three ethyl groups, position 3 and position 7. So it's going to be 3, 3, then 7. Now since this is 3, it's going to be tri. Sorry. Since we have an ethyl group here, we are going to start with the ethyl because while naming, we are going to name them alphabetically. It's going to be alphabetically and E comes before M. So now we have ethyl in position 4. We have 4 ethyl, then another dash. Now we have 3, 3, 3, 3, 7. And 3, 3, 7. Trimethyl. Now our longest chain is what? We have 8 number of carbon atoms here, so it's octane. We have 4 ethyl, 3, 3, 7 trimethyl octane. Now let's try another example. Now let's count again. Let's try counting from this side. We have 1, 2, 3, 4. Now this is 4. I said we are going to try all the possible ways, and we are going to try all the possible ways to see which one is going to give us the number of, to see which one is going to give us the longest chain. Now this is 1, 2, 3, 4. This is 1, 2, 3, 4 also. Now this is, let's start counting from this side. This is 1, 2, 3, 4. Now let's count from this side, and this is 1, 2, 3, 4, 5. So as we can see, since this chain here is 5, while this chain here is 4, we are going to take the one with what? 5, since it is the longest chain. Now here, this is our parent chain. Now this is our parent chain. This is the parent chain, while this methyl group is now the what? The substituent. This is our methyl chain and this is our what? Substituent. Now the name goes like this. Since this is 1, 2, 3, 4, 5. Here we have methyl at position what? 3. We have methyl in position 3. Now our substituent is in position 3. Now let's count from this side. It's still going to be 1, 2, 3. So if you count from this side, the methyl is in position 3, and if you also count in this from this side, the methyl is also in position 3. So we are going to say what? We have 3 methyl. We have 5 number of carbon atoms. 3 methyl. 3 methyl pentane. Now let's take another example. Now our parent chain here is 1, 2, 3, 4. We have 4. 1, 2, 3, 4. We still have 4. We have 1, 2, 3. No, 1, 2, 3, 4. Now 4 is our longest chain, so we'll use this one. So now when we start counting from this side, that's 1, 2, 3, 4. You can see that our two methyl groups, that's the substituents, are in position what? Position 3. While counting from this side, 1, 2. Now our methyl are in what position? 2. So we are going to take this one. So we have 1, 2. We're going to be 2. Since we have two methyl groups, we have 2, 2. I said 2 is what? Di. 2, 2 dimethyl. 1, 2, 3, 4. Our parent is butane. 2, 2 dimethyl butane. So now, from this, we also have cyclic alkenes. Sorry, I didn't mention that earlier. We have cyclic alkenes. We have cyclic alkenes. These ones we did are what? Acyclic. The first example are for acyclic alkenes. That's the ones in straight chain alkenes. Now for the cyclic alkenes, we have cyclo. The prefix cyclo is added before the name of the alkane. If it is a propane and it's a cyclic alkane, a cyclic propane, I want to say this is what? A cyclopropane. Just like this. Have something like this. Now this is what? A cyclopropane. Can have. Now this shows the what? The carbon atoms. We have carbon here, carbon here, carbon here, and carbon here. We have 4 carbon atoms. So this is the what? A cyclobutane. So now, when a substituent is added to this cyclic alkenes, let's use the butane as an example. Sorry, before we move to that, we have cyclobutane, we have cyclopentane, we have cyclohexane. So now sometimes we can see compounds like this. We can see something like this. Or sometimes it can be written like this. So now here, the edges here is showing us that we have carbon atoms. This here is a carbon atom here, a carbon atom here, a carbon atom here, a carbon atom here, carbon atom, carbon atom, carbon atom, and carbon atom. Here, this structure is the same thing as this. We have carbon here, carbon, 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 and here also is a carbon, 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 carbon. If you have any element or you have any substituent other than carbon and hydrogen, it is going to be indicated. Let's say maybe here is OH. If it is OH, it is definitely going to be what indicated. So now, naming this, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 number of carbon atoms. 4, 5, 6, 7, 8. And we have the substituent. The substituent here. Now this carbon is having 3 hydrogen and it's having 2. So now, since we have 8 carbon atoms here, 1, 2, 3, 4. So now our substituent is in position 4. We have our substituent in position 4. Counting from this side, 1, 2, 3, 4, 5, 6, 7, 8. From this side, our substituent is in position 5. So we are going with this. So now the name of this is what? 4-methyl octane. Now this is the same thing as this. It's 4-methyl octane. Some of the rules we should not forget are using this dash between the number and the letter. Then if you have maybe same substituents twice or thrice, if it is 2 times, if it is 2, 3, 4, 5, 2, we use di as the prefix. 3, we use tri. 4 is tetra. 5 is pent, and so on. And while writing the numbers, that if you have more than one, you are going to use a comma between them, not just like this, but like this. And while writing the names, you should not separate the substituent and the parent name. Not something like this. And you are writing the octane here. No, they should always be together. The parent name and the substituent. So now this is it for alkanes. Let's move to alkenes. Now we said alkenes are hydrocarbons. Alkenes are hydrocarbons. Okay, we are going to stop here. In our next class, inshallah, we are going to start from alkenes. So I'll be waiting for your comments, questions, or you have any observation. And please do well by subscribing to this channel. Thank you.